Good morning, dear students. Myself, Dr. Priya, working as Associate Professor in Department of Humanities and Sciences, MLR Institute of Technology. So, in the previous session, so far we discussed about how to prepare synthetic petrol using different methods. So, in that we discussed in the previous session how to prepare synthetic petrol using cracking process. What is cracking process and how many types of cracking process are there? Thermal cracking and catalytic cracking, and in catalytic cracking we have two different types. So, all these topics we discussed in the previous session. So, let us go with today's session. So, in today's session I am going to explain about Fischer-Tropsch method. So, and coming to its introduction part. So, this is a kind of method which is used for preparing synthetic petrol, and this was invented in the year 1925 during World War I and as well as World War II in Germany as a substitute for petrol. So, let us see how we are going to prepare synthetic petrol using this Fischer-Tropsch method. So, as I told you, this Fischer-Tropsch method was introduced or developed by Franz Fischer and Hans Tropsch. These two scientists have developed a method for preparing synthetic petrol in the year 1925, that is during World War I and II in Germany. In order to produce synthetic petrol using, in general, using coal as one of the reactants, synthetic petrol can be prepared. But in the case of this Fischer-Tropsch method, they used water gas. So, general chemical composition of water gas, it is of CO and H2, carbon monoxide and hydrogen. So, and using this water gas, we are going to produce synthetic petrol. So, this is a kind of method that was developed by Franz Fischer and Hans Tropsch in the year 1925. So, how this water gas it is produced means, so it is produced by passing steam over heated coke. So, if steam is allowed to pass through heated coke, then it is able to produce or generate CO plus H2, that is what we call as water gas. So, this water gas now we are going to use as one of the reactants for producing synthetic petrol. So, this is being mixed with hydrogen at a certain temperature and pressure. So, by supplying some amount of temperature and pressure, so this water gas initially it is to be hydrogenated by supplying some amount of temperature and pressure. So, and then that process will start. If you see the process, that means the procedure in which synthetic petrol, how it is produced, water gas is initially purified. So, first we have to hydrogenate water gas by supplying some amount of temperature and pressure. Later it is then purified. For purification it is done for removing the content of sulfur. Sulfur content, it is very toxic in nature. As and when that reactant it is subjected to some kind of chemical reaction, as a result we are getting synthetic petrol. It is a fuel, and fuel it is meant for transportation purpose. If it is used for such kind of applications, then it is able to release oxides of sulfur as one of its products, if it is having more amount of sulfur. So, whenever it is released into the air, it is highly toxic in nature. So, it needs removal. So, during its preparation, that means during the preparation of synthetic petrol, that is its manufacturing only, we are going to remove the content of sulfur as it is considered to be highly toxic in nature. So, this water gas after hydrogenation, it is then subjected to purification by passing through two different chambers, and the first chamber it is meant for removing content of sulfur in the form of hydrogen sulfide. For this we are going to make use of Fe2O3. That first chamber will have some kind of plates. These plates are filled with Fe2O3, which are meant for removing content of sulfur that is in hydrogen sulfide form. After that water gas which is hydrogenated becomes free from H2S, it is then allowed to pass into the second purification chamber, where we have considered a mixture of Fe2O3 and Na2CO3. This mixture of Fe2O3 and Na2CO3 it is meant for removing sulfur in organic form. Sulfur in any organic form gets removed by using mixture of Fe2O3 and Na2CO3. So, after this purification it is done, then the purified water gas which is hydrogenated, purified water gas with hydrogen or hydrogenated purified water gas, it is then allowed to pass into a chamber where some amount of pressure it is supplied, that is around 5 to 25 atmospheres. So, there it is involving in compression, that is compressed, and then it is followed by treating with the catalyst at a high temperature of 200 to 300 degrees centigrade. So, all this process it is carried out in a reactor that is called converter. So what kind of catalyst we are going to make use is here is, it is a mixture of cobalt, thorium, magnesium oxide and then Kieselguhr sand. So what do you mean by this Kieselguhr sand? It is diatomite, or we can call it as diatomaceous earth. So this we can see, or we can notice its formation. It is produced on sedimentary rocks, that is due to fallen leaves, dried leaves of unicellular aquatic plants. So as a result, this Kieselguhr sand will be produced on the surface of sedimentary rocks, that it is mixed with magnesium oxide, thorium and then cobalt. So mixture of all these things we are going to use as a catalyst. So this is the overall view. So let us directly go for this process. So if you see that apparatus, as I told you, we are going to make use of water gas, that is a combination of carbon monoxide and hydrogen. Composition of water gas includes carbon monoxide and hydrogen. First, it is to be subjected to hydrogenation. Hydrogenation means simply adding hydrogen by supplying some amount of temperature and pressure. It is to be added with hydrogen. So this is what we call it as hydrogenated water gas. Hydrogenated water gas. So it is then allowed to pass into the first chamber. What is there in the first chamber? Fe2O3. This Fe2O3, it is meant for removing the content of sulfur in the form of hydrogen sulfide, that is H2S. So what is there in the first chamber? Fe2O3, it is meant for removing content of sulfur that is present in the form of hydrogen sulfide. So there it is totally, it gets removed. So and then that entire content of hydrogenated water gas is then allowed to pass into the second chamber. So in the second chamber, we have considered a mixture of Fe2O3 and Na2CO3. So this mixture, it is able to remove sulfur in any organic form of sulfur if any is present in the raw material that you have taken, that is water gas, so that it is able to remove. So after entering into this second chamber, if any sulfur content is there either in inorganic or organic form, totally it gets removed. So and then the water gas which is hydrogenated, or we will call it as purified hydrogenated water gas, which is free from sulfur content, is then subjected to compression with the help of a compressor by supplying some amount of pressure, that is around 5 to 25 atmosphere. There it involves in compression, or it is compressed. So and then it is allowed to pass into a converter. The converter role, it is meant for converting the entire purified hydrogenated water gas to synthetic petrol. So there we have made use of catalyst. Catalyst is mixture of cobalt, thoria and magnesium oxide along with some amount of Kieselguhr sand. So what is Kieselguhr sand? It is a diatomite or diatomaceous earth that is produced on sedimentary rocks due to unicellular aquatic plants. So that is collected and it is mixed with magnesium oxide, thoria and cobalt in proper proportions that will play the role of catalyst. So that is already placed in the form of a membrane, or we can say a kind of frame in this converter, which is maintained at a temperature range of 200 to 300 degrees centigrade. There the entire hydrogenated purified water gas, that is CO plus H2, gets converted to the form of hydrocarbons. Here we can expect mixture of hydrocarbons. So result will be in the form of two different types of hydrocarbons. What are they? Alkanes and then alkenes. That means saturated and unsaturated unsaturated hydrocarbons will be the result. So the entire treatment gets completed in the converter itself, which is maintained at 200 to 300 degrees centigrade, so that we can expect the formation of mixture of hydrocarbons. So that mixture will contain saturated and unsaturated hydrocarbons, that is alkanes and alkenes, and then it is subjected to cooling. That cooling it is done in the presence of a kind of cooler. That cooler will contain it is filled with water, and this obtained mixture of hydrocarbons are allowed to pass through a pipeline. So there they were subjected to cooling process, and then finally they were subjected to fractional distillation, that is purification, or we can call it as refining. So in the tall fractionating column, as you know very well, because we have already discussed what happens in fractional distillation of petrol. So in the previous classes, so far we discussed. So in this we will get gasoline, that is our required desired final product. Along with that, there is a chance for formation of small amount of heavy oil. So this heavy oil, again it can be subjected to cracking process, thereby producing gasoline or synthetic petrol. So coming to this Fischer-Tropsch method, so what reactant we have considered? Water gas. And what is the chemical composition of water gas? Carbon monoxide and hydrogen. First it is to be subjected to hydrogenation, and then hydrogenated water gas is then allowed to pass into two purification chambers. So in which first purification chamber will have Fe2O3, that is meant for removing the content of sulfur, that is in the form of H2S, and then it is followed by allowed to pass to the second chamber. There we have a mixture of Fe2O3 and Na2CO3. This mixture, it is meant for removing the content of sulfur in the form of organic form. So and then after the entire sulfur content it is removed, that purified hydrogenated water gas, it is then allowed to compress with the help of a compressor which is maintained at 5 to 25 atmospheres, and then this entire content it is allowed to pass into a converter in which we have already considered a mixture of catalyst, that is mixture of cobalt, thorium and magnesium oxide. Along with it, Kieselguhr sand is also considered, and this is maintained at a temperature range of 200 to 300 degrees centigrade. There the entire process gets completed, so that we can expect synthetic petrol formation, but it is produced in the form of a mixture of hydrocarbons, that is in the form of saturated and unsaturated. We need to separate them, and this is done by cooling. First it is done by cooling, that means slowly it has to come to room temperature, and then it is again subjected to fractional distillation for refining, that is for separating that mixture of hydrocarbons that were produced. So as a result we will get synthetic petrol or gasoline. So with this, heavy oil is also obtained. It is again used as one of the reactants for cracking process, so that final product will be gasoline. So this is the process that is involved in Fischer-Tropsch method. So as I told you, that mixture of saturated and unsaturated hydrocarbons were produced in the converter. So if you notice the chemical reaction that is happening, so we have taken carbon monoxide and hydrogen, that is nothing but chemical composition of water gas, and later it is again subjected to hydrogenation. So CO plus H2. So in one form it is able to produce, we are getting mixture. So this is CnH2n, it is the molecular formula for alkenes. Alkenes are nothing but unsaturated hydrocarbons. That means we can notice a double bond formation between two carbon atoms. So alkenes will be produced, along with that water is obtained as a byproduct. And what is the other hydrocarbon that we are getting with this water gas is CnH2n plus 2. It is the general formula for alkanes. So these are alkanes and these are alkanes, and these were then subjected to fractional distillation. Then we will get one liquid that is resembling crude oil, it is obtained at the end, that is what we call it as gasoline or synthetic petrol. In this process we are getting heavy oil as one of the products along with gasoline. That heavy oil can be reused to produce gasoline or synthetic petrol by adopting the method of cracking process. The hot gaseous mixture, it is allowed to pass into a cooler where a liquid that is resembling crude oil it is obtained. That crude oil it is fractionated to give gasoline and heavy oil. So as I told you, this heavy oil can be again subjected to cracking process, so that synthetic petrol can be produced. So better yield we can expect during this Fischer-Tropsch method for gasoline. So that's all for today's session. And so far what we have discussed is only one method in this class we have discussed, that is Fischer-Tropsch method. So which is used for preparing synthetic petrol. So petrol, it is naturally occurring as well as artificially also we can prepare. So in this class we discussed so many methods are there. In today's class we discussed about Fischer-Tropsch method, and this was introduced in the year 1925 by Fischer and Tropsch during World War I and II in Germany. So it is able to produce a better yield for synthetic petrol. So that's all for today's class. In the next class or in the next session, we are going to discuss about what is knocking process and what are anti-knocking reagents, and then what is octane rating and what is cetane rating. How that knocking property is able to influence engines. I mean internal combustion engine ICEs for either two-wheelers or four-wheelers. So that's all for today's session. Thank you so much.